Liam and Noah were not ordinary junk collectors. They were industrial archaeologists of the modern age, making their living by dismantling the heavy skeletons of the 20th century. Their scrapyard, a sprawling acre of mud and twisted metal near the river, was their kingdom. Their latest acquisition was their biggest gamble yet, a colossal, centrifugal dredge pump salvaged from a flooded, abandoned quarry in the Pacific Northwest. Known in the industry as a mud hog, this specific piece of machinery was a leviathan of cast iron and steel, weighing in at over 25 tons. It had sat submerged in brackish water for nearly 60 years, a rusting monument to a bygone era of aggressive industrial mining. The brothers had spent their entire operating capital to transport the beast to their yard, banking on the price of scrap steel and, more importantly, the massive amount of copper they hoped to harvest from the electric motor. The sheer scale of the pump was intimidating. It stood nearly 2 stories high, its volute casing shaped like a prehistoric snail shell, caked in layers of hardened sediment and fossilized algae. The brothers began the dismantling process at dawn, the air filled with the sharp scent of ozone and acetylene. Their plan was methodical: strip the external piping, remove the massive impeller housing, and finally, extract the prize, the 2,000 horsepower electric motor that served as the pump's beating heart. They worked in silence, the rhythm of their sledgehammers echoing off the corrugated metal fences of the yard. The bolts holding the casing together were the size of forearms, rusted solid, requiring intense heat from the cutting torches to break free. Molten iron dripped onto the muddy ground as they surgically removed the outer armor of the machine. As the sun climbed higher, the first anomaly appeared. Usually, pumps of this era were built with crude, heavy castings, marked by rough surfaces and simple engineering. However, as Liam cleared away a thick layer of dried mud from the motor's mounting plate, he revealed steel that was surprisingly smooth, almost polished. It showed no signs of pitting or deep corrosion, which was impossible for untreated steel that had been underwater for decades. It was a high-grade alloy, something far more expensive than cast iron. Noah noticed the precision of the machining on the flange bolts. They were not standard industrial grade, but appeared to be custom milled with a thread pitch they didn't recognize. The brothers exchanged a look. They had bought this thing for weight, but the craftsmanship suggested it was built for something far more critical than just moving mud. Hey everyone! We are taking a brief pause from this heavy lifting because we need your help to keep this channel running. We are incredibly close to hitting our goal of 10,000 subscribers, and we need you to smash that subscribe button right now. It helps us fund these crazy salvage projects. Also, if you're enjoying the mystery, consider using the Super Thanks feature below to support the channel directly. We also want to know our audience better. Drop a comment down below and tell us which country you are watching from. We love seeing our global salvage community grow. Now, let's get back to this mystery motor. With the outer casing finally removed, the massive electric motor was fully exposed. It was a cylindrical beast, painted a dull, lead-gray color that had barely faded. Unlike standard motors that have cooling fins and vents, this unit was completely sealed, a smooth, hermetic cylinder with no visible way to access the internal windings. This was highly unusual for a 2,000 horsepower unit, which would generate immense heat and require substantial airflow. The identification plate, usually a brass rectangle riveted to the side, was missing. In its place was a stamped serial number directly on the housing, X77, Proto, USN. The USN suffix hinted at a naval connection, possibly the U.S. Navy, which made no sense for a piece of mining equipment found in a civilian quarry. They decided to crack the seal. Using an angle grinder with a diamond-tipped blade, Noah began to cut along the weld seam of the motor's rear maintenance hatch. The steel was incredibly hard, eating through 3 cutting discs before they made a breach. As the metal finally separated, a hiss of escaping gas whistled through the yard. The motor had been pressurized with an inert gas to prevent corrosion. This level of preservation was unheard of for a dredge pump. They pried the heavy steel cap off, expecting to see the dull gleam of thick copper coils. Instead, they were met with a sight that defied their knowledge of mechanics. The interior wasn't filled with copper wire. It was packed with a dense, silvery array of rectangular plates and intricate, glass-like insulators. The windings were made of a metal that shimmered with an iridescent hue, looking more like jewelry than industrial salvage. This wasn't just a motor, it was a prototype of a propulsion technology that had likely been discarded or stolen half a century ago. The brothers realized that melting this down for scrap would be a crime against history, and a financial disaster compared to what it might actually be worth. Liam and Noah stood paralyzed in the fading twilight, the strange silvery gleam of the motor's interior reflecting in their wide eyes. The initial shock of the escaping gas had settled, replaced by a feverish curiosity. This was not the anatomy of any electric motor they had ever encountered in their combined 20 years of salvage work. Standard motors were predictable beasts, heavy copper coils wrapped around iron cores, insulated with varnish and paper. But this machine was alien. The internal structure was composed of thick, rectangular bars arranged in a complex, geometric lattice, separated by translucent spacers that looked like high-grade quartz rather than glass. The bars themselves were not copper-colored. They possessed a distinct, milky white luster that seemed to defy the grime of the scrapyard. Noah, always the more pragmatic of the two, broke the trance. He scrambled down the side of the massive pump and ran to their workshop, returning moments later with a heavy-duty magnet and a handheld X-ray fluorescence (XRF) analyzer, a pricey tool they used to identify high-value alloys in aerospace scrap. He climbed back up to the open hatch where Liam was already carefully wiping away the protective grease from one of the rectangular bars. Noah held the magnet close to the metal. It didn't stick. The material was non-ferrous. That ruled out steel or nickel. It behaved like copper or aluminum, but the color was wrong. It was too heavy, too dense, and far too bright to be aluminum, and it lacked the reddish hue of copper. With trembling hands, Noah pressed the nose of the XRF gun against the clean surface of the bar and pulled the trigger. The device emitted a soft beep as it bombarded the metal with X-rays to determine its elemental composition. The screen flickered for a few agonizing seconds before displaying the results. Noah stared at the readout, blinked, and then wiped the screen with his thumb, convinced it was a glitch. He tested a different bar. The result was identical. He turned the screen toward Liam without saying a word. The display read AG 99.9%. It was pure silver. The realization hit them with the force of a physical blow. The windings of this massive 2,000 horsepower motor were not made of copper wire. They were solid, cast bars of bullion-grade silver. In the mid-20th century, during wartime shortages of copper, the U.S. government had occasionally used silver from the Treasury for critical industrial applications, most notably in the Manhattan Project's electromagnetic isotope separators. It appeared that this X-77 prototype had been built during a similar period of strategic resource allocation or for a project where the slightly higher conductivity of silver was deemed essential for performance, regardless of the cost. Liam grabbed a tape measure and a calculator. He measured the dimensions of the exposed silver bar, 3 inches wide, 1 inch thick, and curving deep into the machine's core. He quickly estimated the number of bars visible in the stator assembly. The density of silver was significantly higher than copper. If the entire stator was wound with these solid silver bus bars, they weren't looking at a few pounds of scrap. They were looking at thousands of pounds of precious metal. The brothers did the rough math, glancing at the current spot price of silver on their phones. The scrap value of the steel they had bought the pump for was maybe $2,000. The value of the silver sitting inside the motor housing was potentially in the millions. However, the discovery raised more questions than it answered. Why was a multi-million-dollar government asset inside a dredge pump in a civilian quarry? They needed to understand the machine's provenance before they could even think about processing it. Melting down U.S. government property, even if it was abandoned for 60 years, could land them in federal prison rather than a mansion. They decided to dismantle the front bearing assembly, hoping to find a builder's plate or a maintenance log that had survived the decades. Working under floodlights now, the night air cold around them, they unbolted the heavy front bearing cap. Behind it, nestled in a dry, grease-packed cavity designed to keep the bearings lubricated, they found a sealed brass canister. It was a document tube, screwed directly into the casting, a common feature on high-end naval machinery to ensure schematics stayed with the engine during combat or disaster. Noah unscrewed the cap. It was stiff, but the threads were well greased and turned. Inside, wrapped in oilcloth, was a roll of stiff, blue-tinted paper. They carefully unrolled the documents on the flat surface of the pump's casing, weighting the corners down with heavy wrenches. These were the original blueprints. The header on the documents confirmed their suspicions and escalated the situation entirely. The text read, Project Clarion, Department of Naval Research, 1953. Prototype Silent Drive Propulsion Unit. The schematic showed the motor being installed not in a dredge, but in a testbed for a submarine stealth program. The notes in the margins, handwritten in fading ink, detailed the use of Strategic Reserve Material Type A for the windings to minimize electrical resistance and heat signature. The dredge pump was a cover. The motor was never meant to pump mud. It was being stress-tested under load in a remote quarry to simulate the drag of a submarine propeller, hidden in plain sight as mining equipment to avoid Soviet espionage. The brothers looked from the blueprints to the shimmering silver bars. They had purchased a piece of Cold War history that had been effectively erased from the books. The USN on the serial number was genuine. The quarry had likely been a front company or a subcontractor that went bust, and when the facility flooded, the classified prototype was left to rot at the bottom, assumed lost or destroyed. Now, it was sitting in their yard, a massive silver bank vault disguised as a rust bucket. But the blueprints revealed one more detail, a warning stamped in red near the bottom of the page. Component contains hazardous material. See Section 4. The brothers froze. They had been so focused on the silver, they hadn't considered what else might be inside a 1950s experimental engine. The red ink on the blueprint, see Section 4, acted like a splash of cold water on the brothers' feverish excitement. Liam carefully turned the brittle pages of the schematic until he reached the referenced section. The text was technical, dry, and terrifying. It detailed the insulation spacers used between the massive silver bars. To handle the extreme thermal loads of a silent drive propulsion system, the naval engineers had not used glass or standard porcelain. They had utilized beryllium oxide, BO, ceramics. In its solid form, the material was harmless and an incredible heat conductor. However, if the ceramic was chipped, crushed, or ground during the dismantling process, it would release microscopic dust. Inhaling even a minute amount of this dust could cause chronic berylliosis, a fatal, incurable lung disease. They had been about to attack the motor with angle grinders and sledgehammers. If they had done so, they wouldn't just be rich, they would be dead men walking. The atmosphere in the scrapyard shifted instantly from a celebratory treasure hunt to a high-stakes hazmat operation. The greed for the silver was still there, but it was now tempered by the cold reality of industrial toxicity. They retreated to their on-site office to formulate a new plan. They couldn't just cut the silver out, they had to surgically extract it without disturbing the white ceramic spacers wedged between the bars. This required a level of finesse rarely seen in a scrapyard. They donned full-face respirators with P100 filters, disposable Tyvek suits, and heavy chemical-resistant gloves. They looked less like salvage mechanics and more like a forensic team entering a contamination zone. Returning to the hulking machine, they rigged a complex system of pulleys and chains to the overhead gantry crane. The goal was to lift the central rotor, the spinning part of the motor, straight up and out of the stator housing. This would expose the silver windings lining the walls of the casing without the need for abrasive cutting. The rotor itself weighed nearly 5 tons. It was a solid steel shaft clad in iron laminations, and the clearance between it and the fragile, toxic beryllium spacers was less than 2 millimeters. If the rotor swung or tilted during the lift, it would crush the ceramics, releasing the deadly dust and contaminating the silver. Noah manned the crane controls, his movements microscopic. The massive chains pulled taut, singing under the tension. The motor groaned, a deep metallic sound of rust breaking its bond. Liam stood on top of the casing, guiding the shaft with his gloved hands, watching the gap with the intensity of a diamond cutter. Inch by agonizing inch, the 5-ton steel cylinder began to rise. The silence of the yard was broken only by the electric hum of the crane and the heavy breathing inside their masks. Sweat poured down their faces, stinging their eyes, but they couldn't wipe it away. A sudden gust of wind rocked the suspended load, and the rotor swayed dangerously close to the white ceramic teeth. Liam signaled a hard stop. They waited for the pendulum motion to cease, their hearts hammering against their ribs. With a final steady pull, the rotor cleared the top of the housing and swung free. They lowered it gently onto a bed of wooden pallets far away from the work zone. They returned to the hollowed-out carcass of the motor. With the rotor gone, the interior was fully revealed under the harsh work lights. It was a breathtaking sight. The stator was a cathedral of precious metal. The silver bars, now clearly visible from top to bottom, were arranged in perfect, gleaming columns, separated by the deadly white spacers. It was the most expensive industrial component they had ever laid eyes on. Liam reached in and wiped a gloved finger along one of the heavy bars. It was cool and smooth. He did a quick mental calculation based on the volume they could now see. The initial estimate was low. There wasn't just 1,000 pounds of silver here. The windings were double-layered. They were looking at close to 3 tons of high-purity silver, worth nearly $2 million on the spot market. But the blueprints had one more secret to reveal, a detail they had missed in their panic over the beryllium. As they inspected the bottom of the empty motor casing, looking for the mounting bolts to begin the careful extraction of the silver, Noah's flashlight beam caught a discrepancy in the floor of the housing. There was a raised metal box, welded directly to the frame, sitting right where the main power cables entered the machine. It looked like a junction box, but it was sealed with heavy lead rivets and marked with a distinct skull and crossbone symbol, different from the standard poison warning. They consulted the Section 4 notes again. The text described a security denial system. In the event of the prototype falling into enemy hands, specifically Soviet forces, the motor was equipped with a thermite-based scuttling charge. This device was designed to ignite, burn at 4,000 degrees Fahrenheit, and melt the silver windings into a useless, fused lump of slag and ceramic, destroying the technology and the value simultaneously. The trigger mechanism was linked to the casing bolts. If the motor was disassembled without first disarming the charge, the thermite would fire. The brothers stared at the lead-sealed box at their feet. They had successfully removed the rotor without triggering it, likely because the trigger was located on the stator bolts, which they were about to attack. They were standing inside a giant metal bucket with $2 million in silver and a dormant incendiary bomb designed to turn it all into molten waste. The dampness of the quarry might have ruined the ignition primer, but thermite itself doesn't expire. If they used a torch or a grinder near that box, or if they loosened the wrong bolt, the resulting chemical fire would be unquenchable. They weren't just hazmat cleaners anymore. They had to become bomb disposal experts. The scrapyard had become a bomb disposal site. Liam and Noah stood motionless over the open carcass of the motor, staring at the lead-sealed box that stood between them and a life-changing fortune. The security denial system, described in the blueprints, was a crude but effective piece of Cold War engineering. A tension steel cable ran from the box to the main structural bolts of the stator. The logic was simple. If the bolts were loosened to remove the silver, the cable would slacken, a spring-loaded striker would fire inside the box, and the thermite would ignite. At 4,000 degrees, the reaction would turn the 3 tons of silver into a worthless, radioactive-looking puddle of slag within seconds, while likely burning down their entire workshop in the process. They couldn't cut the cable, as that would simulate the bolts loosening. They couldn't freeze the box, as the sudden thermal contraction might trip the sensitive spring mechanism. They had to outsmart the physics of the trigger. Noah, whose background was in mechanical rigging, proposed a solution that was as brilliant as it was dangerous. They would create a false tension bridge. Using heavy-duty C-clamps and a piece of steel flat bar, they could clamp the tension cable upstream of the trigger box, securing it directly to the box's own mounting bracket. This would isolate the trigger from the rest of the machine. Essentially, they would be hot wiring the bomb to think the motor was still fully assembled, even as they tore it apart. The operation required the steady hands of a surgeon. Liam held the heavy steel flat bar in place, his muscles trembling slightly from the adrenaline and the weight of the protective gear. Noah positioned the industrial C-clamps. One slip, one dropped wrench, or one over-tightened turn that caused a sudden vibration could release the firing pin. The silence in the yard was absolute, save for the distant sound of the river and the muffled rasp of their breathing through the P-100 filters. Noah tightened the first clamp. The cable groaned under the new pressure. They froze, eyes locked on the lead box. Nothing happened. He tightened the second clamp. The tension was now transferred. The cable leading to the casing bolts went slack, but the cable entering the trigger box remained taut, held by their makeshift bridge. With a nod that felt like a shout, Noah took a pair of hydraulic bolt cutters and severed the cable connecting to the stator. A sharp snap echoed through the casing. The trigger box didn't react. The bypass was successful. The bomb was now an inert, confused metal box. They carefully unbolted the box from the frame, carrying it like a sleeping cobra to the far end of the yard, where they gently submerged it in a barrel of waste oil to dampen any potential spark, intending to hand it over to the authorities later. Now, the harvest could begin. The threat of the thermite was gone, but the ghost of the beryllium dust remained. They couldn't just rip the bars out. They set up a continuous water misting system, soaking the interior of the stator to bind any ceramic particles to the sludge in the bottom. Working in the mud and the wet, they began the grueling physical labor of extraction. Each silver bar was a heavy, slippery crescent of wealth, weighing nearly 50 pounds. They had to be pried loose from the ceramic teeth one by one. It was back-breaking work. For 3 days, the brothers lived in their Tyvek suits, sleeping in shifts, eating cold food, driven by the mounting pile of metal on the pallet. As they worked, they began to appreciate the insane engineering of the Project Clarion motor. The silver wasn't just scrap, it was machined to tolerances that were invisible to the naked eye. The bars interlocked like a puzzle. By the time the stator was empty, leaving only the hollow white skeleton of the beryllium ceramic frame, they had filled 4 heavy-duty shipping crates. The pile of silver was mesmerizing. It was dark with grease and oxidation, but where their pry bars had scratched the surface, the brilliant moon-white luster of pure silver shone through. They moved the crates into their secure warehouse using the forklift. The suspension of the machine groaned under the weight. They did a final tally. They had recovered 128 individual bars. Based on the volume and density, the total weight was approximately 6,200 pounds, over 3 tons of bullion-grade silver. At the current market price, the raw metal alone was worth roughly $2.4 million. But as they began to clean the bars with degreaser to prepare them for sale, they discovered a complication that threatened to derail everything. Under the layers of 60-year-old varnish, stamped deep into the face of every single bar, was not a standard hallmark. There were no .999 stamps or commercial refinery logos. Instead, each bar bore the eagle crest of the United States government and the terrifying inscription, U.S. Treasury, Strategic Stockpile, Class A Material. Below that was a warning. Possession by unauthorized personnel is a federal offense. They weren't holding scrap metal. They were holding stolen government property. Even though they had bought the pump legally, the silver inside it was technically still part of the U.S. Strategic Reserve. If they walked into a standard refinery or a We Buy Gold shop with a truckload of bars stamped U.S. Treasury, the police would be there in 5 minutes. They had recovered the fortune, but they had no legal way to convert it into cash. They were millionaires on paper, but in reality, they were sitting on a federal crime scene. They needed a lawyer, and they needed a specialized assayer who dealt with recovered historical assets. Liam remembered a contact from an old job, a high-end metallurgist named Dr. Eris who worked with maritime salvage firms to authenticate gold from shipwrecks. It was a long shot, but he was the only person who wouldn't immediately call the FBI. They loaded a single bar into the back of their pickup truck, covered it with an oily rag, and drove 4 hours to the city. The meeting took place in the back room of a nondescript industrial lab. Dr. Eris, a small man with thick glasses, took one look at the bar, then at the stamp, and then at the brothers. He didn't weigh it. He didn't test it with acid. He simply took off his glasses and rubbed the bridge of his nose. "Do you have any idea what you boys have found?" he asked quietly. "This isn't just silver. This is Manhattan silver." This metal was likely part of the loans made to the atomic program in the 40s and 50s. Most of it was returned to West Point. This is the lost leakage. You can't melt this. If you melt this, you are destroying an artifact. But if you try to sell it, you're trafficking government property. He paused, looking at the door as if expecting federal agents to burst in. "However," he added, a glint appearing in his eye, "there is a legal loophole. But it involves making a phone call that you cannot take back. It involves the Defense Logistics Agency. If we do this right, you get a finder's fee. If we do it wrong, you get handcuffs. Do you want me to make the call?" The silence in Dr. Eris's office was heavy, broken only by the hum of the air conditioner. Liam and Noah exchanged a final, wordless look. The choice was binary. Try to sell the silver on the black market, risking decades in federal prison for trafficking stolen government property, or trust a vague legal loophole that might leave them with nothing but a thank-you note. Noah nodded. Liam turned to the metallurgist and gave the signal. Dr. Eris picked up the phone and dialed a number that didn't appear in any public directory, connecting directly to the Defense Logistics Agency's Critical Materials Recovery Division. The call was short, cryptic, and terrifyingly efficient. "Asset located. Condition stable. Project Clarion. Yes, the winding material. We are holding." The response was immediate. Within 24 hours, the muddy, chaotic atmosphere of the brothers' scrapyard was transformed into a rigid zone of federal authority. 3 black SUVs and a heavy transport armored truck rolled through the rusted gates, flanked by a Naval Criminal Investigative Service (NCIS) escort. The brothers stood by their office, watching as men in suits and military uniforms stepped into the mud. They weren't in handcuffs, but they weren't exactly free, either. A stern-faced commander approached them, not with a warrant, but with a clipboard. He introduced himself as a liaison for the Strategic Materials Stockpile. He asked to see the X-77 unit and the recovered collateral. The brothers led the delegation to the warehouse. When the crate lids were pried open, revealing the rows of silver bars stamped with the Treasury seal, the mood in the room shifted from suspicion to reverence. The government officials weren't looking at scrap. They were looking at a lost regiment of soldiers returning home. The commander ran a gloved hand over the bullion. He confirmed the Manhattan silver theory. This metal had been loaned to the Navy by the Treasury in 1953 for the silent drive experiments, and when the project was scrubbed, the paperwork was botched. The motor was listed as destroyed, but had actually been sold as surplus junk to the quarry. For 60 years, the U.S. government had been looking for these missing 3 tons of strategic reserves. The turning point of the interaction came when Noah pointed out the oil barrel in the corner. He explained, with calm technical precision, how they had identified the thermite security denial system, bypassed the tension trigger using the C-clamps, and neutralized the device without detonating it. The Navy EOD, Explosive Ordnance Disposal, officer who accompanied the team went pale. He carefully inspected the submerged trigger mechanism and then looked at the brothers with genuine astonishment. "You boys didn't just find the silver," he said, his voice dropping. "You saved the evidence. If that thermite had fired, this would be a puddle of worthless slag. You did a job better than my own guys could have done in the field." This competence changed their status from suspects to specialized contractors. The legal loophole Dr. Eris had mentioned was the Section 2404 Recovery Award. Because the brothers had voluntarily reported the find and had protected the asset from destruction, the thermite, they were not treated as thieves, but as salvers. Under maritime and federal salvage laws, recovering lost government property entitles the finder to a percentage of the asset's value, known as a salvage award, especially when the recovery involved significant risk and technical skill. The risk was the beryllium and the bomb. The skill was the surgical extraction. The negotiation was handled by the law firm Dr. Eris had recommended. The government reclaimed the silver. The armored truck was loaded with the heavy crates, the suspension groaning as the Project Clarion hoard finally left civilian hands. The blueprints and the empty motor casing were also seized for the Naval Archives, as they were classified Cold War documents. The scrapyard felt suddenly empty, the adrenaline crash hitting the brothers hard. They were left with a muddy yard, a dismantled pump, and a promise of a federal review. 6 months later, the letter arrived. It was a standard government envelope, unassuming and thin. Inside was a treasury check and a letter of commendation from the Department of the Navy. The government had appraised the silver not just at spot price, but at a strategic replacement value. The salvage award was set at a staggering 65% of the recovered value, a premium paid to encourage the return of lost nuclear-era materials. The check was made out to their salvage company for $1.85 million. The gamble on the rusty snail shell had paid off beyond their wildest dreams. Liam and Noah didn't blow the money on fast cars. They invested it back into the dirt. They purchased a brand-new fleet of excavators, a high-tech magnetic separation plant, and, most importantly, the neighboring 10 acres of land to expand their yard. They became the premier industrial salvage firm in the state, specializing in high-risk, high-complexity demolitions. They kept one souvenir: the massive, snail-shaped volute casing of the dredge pump. The outer iron shell that had hidden the silver secret was sandblasted, painted a glossy industrial blue, and mounted on a concrete plinth at the entrance of their new facility. To passers-by, it was just a cool piece of old machinery. But to Liam and Noah, it was a monument to the greatest find of their lives. It was a reminder that in the world of salvage, you never judge a book by its cover, and you certainly never judge a motor by its rust. The giant pump was bought for pennies, but the heart inside it beat with a silver pulse that changed their future forever. Thanks for watching this incredible journey into the hidden history of American industry.